Okay, so this is an interesting question. It's question 7 from June 2013 Edexcel. So figure 2 shows the sketch of the curve C with parametric equations, yada yada yada. A. Find the gradient of the curve at the point where t equals pi over 6. So what I do is, this is a big clue here, take the gradient. So we're going to have to find the derivative of this and then plug in t equals pi over 6 into that derivative to find the gradient at that point. So first thing we should do is differentiate both of these equations with respect to t. So x equals 27 sec cubed t. What I like to do is I like to think of this as saying the same as 27 sec t all cubed, and that gives us a clue as what to do next. We're going to have to use the chain rule. So the derivative with respect to t equals 3 times 27, which is 81, sec squared t, and times the derivative of the inside of the brackets, which is sec t tan t. And then we've got to do the same thing for y equals 3 tan t. So dy by dt equals 3 sec squared t. Okay, so how do we find dy by dx? All we want to do is take the inverse of this and multiply it by this. So dy by dt equals times dt by dx. I like to think of these two as cancelling each other to give us dy by dx. So let's do that. So that's going to be 3 sec squared t times 1 all over 81 sec cubed t tan t. So a few things can cancel here. Obviously the 3 can cancel out with the 81 to give us 27, and the sec squared t can cancel out with the sec t. And this is going to give us 1 all over 27 sec t tan t. Okay, so let's just get this in an easier form to use. So if we remember, sec t is the same thing as saying 1 over cos t. Okay, and tan t equals sine t over cosine t. This can become, or is equal to, cos t, because it's 1 over cos t, all over 27. Now 1 over sine t over cos t is going to give us cos t over sine t, so times cosine t over sine t. Okay, so this is the same thing as saying cos squared t over 27 sine t. All we need to do from here is just plug in t equals pi over 6. Do that on your calculator. So type in cos pi over 6 squared over 27 sine pi over 6, and that should give you a value of 1 over 18 for the gradient of the curve C at the point where t equals pi over 6.